so I'm going to go over the EOC Benchmark 3 review part 2. And if you hear any weird noises, it's because Jojo the pug is sitting here with me listening. And she kind of snorts a little bit. All right, so question number 1. One function is given as f of x equals x squared minus 4x plus 10. The graph of another function is shown below. So the graph of the other function is right here, and this is g of x right here. Let me get it written in there. So that's our g of x. So that's the graph that's being shown right there. So they want to know which of the following statements is true. So we have one graphed and one is not graphed. So if I were you, I would take this right here and graph it in your calculator underneath the graphing function. So graph in or on calculator. Calc. Jojo's trying to sit in my lap, so it's making it hard for me to actually write because I have to write around her. So it says both the f function, the g function have the same minimum values. Well, a minimum value is where the vertex is. So on this one, the minimum value is 2, 2. Or they both have y equals 2 as the x-axis. Well, this whole y equals part as the axis of symmetry, that's not possible in this particular graph because the axis of symmetry is a vertical line when parabolas open up or down going through the x-axis. So since it's a vertical line going through the x-axis, its equation is x equals, and it's going through 2 on the x-axis, so the equation is x equals 2. Both of these graphs, the one that's graphed and the one that's not, open up. And so because it says y equals, it is not possible for B to be the answer. And then C says the f function has a minimum value 4 units above the minimum value of g of x. Well, if that's true, 4 units above, and if you notice the y-axis is going by units of 2, 4 units above would be right here at 2, 6. So that would be 4 units above. And then answer D says the f function has an axis of symmetry 4 units above the axis of symmetry of G. Well, axis of symmetries for parabolas that open up or down are vertical. So I can't really be up or down to a vertical line. I can be right or left, but I can't be up or down. So answer D is not even feasible. So that one's out. So I'm now down to a 50-50 shot. So if you graph this in your calculator, graph the f function, you will note, and then you might actually have to zoom out in order to see the graph. It depends on where you have your window. But you want to make sure that you can see the actual vertex, which is your minimum value for this particular graph because it opens up. And if you do that, you do come up with a minimum value of being right here at 2, 6. So that means that the answer right here has a minimum value 4 units above the minimum value of the g function. Answer C is our correct answer. Next question. Whoops, let me erase that. Try to get my moving function. All right, so question 2. This bigger. Question 2 says the formula for the volume. Oh, in question 2, you need to make a correction. So none of these answers printed out correctly. So the correct answer choices for A would be W equals V divided by L times H. For answer B, W equals L times H divided by V. Answer C, W equals V times L divided by H. And answer D, W equals V times W divided by L. So the question is asking us, well, it basically says the formula for the volume of a rectangular prism is this. What is the formula when solved for W? So keyword solve for W. Notice all of these are solved for W. The only one that stands out as odd is D, because if you solve for W, there shouldn't be any W's on the other side of the equation. So I know just starting off that D cannot possibly be the answer. So I'm now down to a 1 in 3 chance. So I'm going to look at the equation that or the variable that I want to solve for, and I want to solve for the W right there. So look at what's happening to W. W is currently being multiplied by L and by H. So if I want to undo multiplication, the opposite of multiplying would be to divide. So I'm going to divide W by L and by H. What I do to one side, I must do to the other side. And so my H's cancel, my L's cancel, and I'm left with W by itself. So I end up with W, and I'm going to flip this around. So I'm putting W on the left, and then volume, which is V, over L times H. So there's my answer, which matches exactly with answer A. So looking at question 3, question 3 also, by the way, it's the only other question that I know of off the top of my head that also had a printing error. So you need the system of equations. So 1.5, got to add this in, can't solve the problem without it. X plus 2y equals 20. And then 2.5x minus 5y equals negative 25. So it says that Felipe is solving the system of equations. He got 4, 7 as his solution. Is Felipe correct? Well, again, this system of equations is going to graph, hopefully, as 2 intersecting lines. And wherever they intersect, that is the solution. So he's saying the solution on the coordinate grid comes out to be an x value of 4 and a y value of 7. And so you have some answer choices, 2 no and 3 yes, with various reasons. So there's a couple ways that you could answer this question. I mean, you could start off with just plugging in 4 for x and 7 for y into both equations and seeing if it's a common solution. If it is, that's the answer, because if they're only going to have one common solution. So let's go ahead and do that. So I'm going to take the first equation, 1.5, and instead of x I got parentheses, plus 2, and instead of y, I'm using parentheses, equals 20. So we're going to plug in our x value. This is our x value, 4, and our y value is going to be 7. So 1.5 times our x value of 4 plus 2 times our y value of 7, and we're going to see if that equals 20. So I'm going to throw that in my calculator, 1.5 times 4 plus 2 times 7, which is 14. And the left side turns out to be 20, and that is exactly equal to the right side. So that solution works because the left side equals the right side, but it has to work in both equations. So we're going to check it in the second equation. 2.5 parentheses minus 5 parentheses equals a negative 25. So our x value is 4 and our y value is 7. So plugging that into the calculator, 2.5 times 4 minus 5 times 7 equals negative 25. And so, let me get black, so negative 25 does indeed equal negative 25. So since it worked in both equations, the answer is yes, because the solution checks, that's what we just did, for both equations. Next question. If you listen really carefully, you can hear JoJo snoring. She cracks me up. Okay. And her face is like right by the microphone. All right, so for question 4, it says the length of a rectangle is 5 more than twice the width. So as we look at this question, 5 more than twice the width, they are describing the length. What we don't know is the width. So they're saying the length is 5 more than twice the width. If we knew what the width was, we could figure out the length. And then they continue on to say if the perimeter of a rectangle, so perimeter formula of a rectangle should be popping up in your brain. It's understood that you know this. So if you don't, you need to learn it. So the perimeter formula of a rectangle is twice the length plus twice the width, or add up all sides. And there's 4 sides to a rectangle, which is 34. So I'm going to replace 34 for perimeter equals. And then I'm going to draw a picture. So I'm going to set up a little bit of a 4-step plan here. So if they're describing something to me, I'm going to draw a picture of it and label what I know. I don't know the width, so I'm going to let that be W. They did describe the length as being 5 more than, so that would be 5 more than is plus. Twice the width means you're doing 2 times W. So 5 plus 2 times W represents that length. So then I'm going to take my formula that I'm supposed to know and plug in the values that I just determined. So my length is 5 plus 2W. And then since I don't know width, I'm just going to keep it as W. And I'm going to solve. So to solve, I need to distribute on this right side the 2 into the parentheses. So I get 34 equals 2 times 5 is 10. 2 times 2W is 4W plus 2W. Then I want to collect like terms, and there's my W terms. Same side, we're just going to collect, so we're just going to add in and figure out what they are. So 34 equals 10. 4W plus 2W is 6W. So now I have all of my variable terms on one side, but they are not by themselves. So I want to get this by itself, so it stays. The 10 has to move. The opposite of a positive 10 is negative 10. So the 10's cancel. And on the left side, you get 24 equals 6W. Focusing on my variable, 6 is being multiplied to W, so to undo multiplication, I'm going to divide both sides by 6. And so I get 4 is equal to W. And so typically here I answer the question right here, but it says, what is the length? Well, so I'm going to take my scribble away. I do need to keep going. So I found the width, but the question is asking for the length. Notice that width is one of our answer choices. Don't get sucked into that. You have to go back and look. What is the length? That's what they're asking. We define the length here as 5 plus 2W. So because length equals 5 plus 2W, and we know the value of W because we just found it is 4, we are going to replace that W with a 4 and do the math. So L is equal to 5 plus 8, so our length is 13. And so that would be answer C. All right, question 5. What is the value of y at which the line 6x plus 2y equals 30 and y equals negative, 0.5x plus 1 intersect? Well, you need to take, whoops, my pen went crazy. Let's erase that. You need to take each of these equations here and plug them into your calculator and graph them and find the intersection under GSolve or under the second calc menu if you have a TI, GSolve if you have a Casio. But first they have to be solved for y. One equation is solved for y for us, and that's this one, so we don't have to do anything with this one. But we do have to solve this equation for y. So if I'm solving for y, this is the only term that has y in it, so I'm going to keep it on the left and move the 6x to the right. The opposite of a positive 6x is a negative 6x. So I'm going to subtract 6x from both sides. The 6x's cancel on the left. I get a 2y equals 30 and a negative 6x are not like terms. Typically we write our x term first, so we have negative 6x and then a positive 30. To solve for y, I need to undo 2 times y by dividing by 2. What I do to one side I do to the other, and I have to do to every term on the other side. So all terms get divided by 2, and I get y equals negative 6 divided by 2 is negative 3x. 30 divided by 2 is positive 15. So now I have both equations solved for y. I'm going to put the right side of the equations into the graphing function. Oops, hang on. Okay, so I'm going to clear out what I put in there yesterday. Alright, so I'm putting in 0.5x plus 1 into one line, hit enter or execute, and then negative 3x plus 15, enter or execute, hit your draw or your graph, and you want to make sure that your window is showing the intersection of the two lines. If it doesn't, you have to zoom in or out. Go to Second Calc or G-Solve, which would be Shift and then G-Solve, and then we are finding the intersection between the two lines. So use that command, and you get an intersection of, oops, sorry Jojo, a x value of 4 and a y value of 3. So you got to go back and look. What is the question asking? It wants the value of y. So that means that we're looking at 3. So the answer is 3. Notice that they had the value of x, which was 4, also as a choice there. So you do need to be careful. Next question. Whoops, not next question. I forgot that there's question number 6 down below. All right, which of these measures is the most precise? Most precise. So the smaller the measurement, the more precise. So we have millimeters here and centimeters here. Since millimeters are smaller, these are not going to be the most precise. Then the more decimal places you go out to, the more precise your answer. So because A has 1 decimal place, A is going to be your most precise measure. Now the next question, number 7. On number 7, they're asking you what is f of 2 for this function f. So 2 represents the x value, and they're asking you to take 2 and replace every x you see here with 2. So you're essentially evaluating the function when x is 2. So to write it correctly, you would do f of 2 equals, and then I'm going to rewrite the equation, but everywhere I see an x, I'm using parentheses. They're called your substitution parentheses. All right, we're going to plug in our value for x, which is 2, and you're just going to run the right side into your calculator. So if I throw this into my calculator, I have 2 parentheses, and I'm using it exactly as I see it. You're going to use either your squared button or your caret to raise it to the power of 2, plus 6, parentheses 2 and parentheses, and then minus 5. And f of 2 is equal to 15. So your x value, and essentially you can look at it as an ordered pair. This is your x value. So your x value is 2, that's your input. Your output is your y value, which is 15. Now they want f of 2, so they're really looking for that 15, so C is the answer. All right, so question 8. A group of friends are studying linear equations for their math class, so it's equation of a line. They consider the equation shown, y equals 3x plus 4. Each friend makes a statement regarding the solution of this linear equation. Which friend is correct? Amanda says that there's only one solution, 1, 7. Well, there's actually an infinite number of solutions. So this graph, y equals 3x plus 4, is going to look like, Like maybe here's the coordinate grid. Maybe I'll move this down to here. Okay. Okay, so it's a little off, but we don't let that bother you. So 1, 2, 3, 4. So it looked like this. So this might be what the graph, it's just a sketch of that line looks like. So everywhere on this line, and this is an infinite line, it goes infinitely in both directions, any ordered pair that's on this line is considered a solution. So Amanda is incorrect that there's only one solution. There is an infinite number of solutions. So we are going to cancel Amanda's thought there. Then B says, Baraz says that there are exactly 5 solutions. So for the same reason that we're canceling out Amanda's opinion, we're going to cancel out Baraz's because, again, there should be an infinite number. Consuelo says that there are an infinite number of solutions, all points that lie on the graph, all points that lie on the graph of the line. Consuelo is correct. Let's see what Darius says. So Darius says that there are an infinite number of solutions, all points in the coordinate plane. It's not the coordinate plane, it's that lie on the graph itself. So D is wrong. Next question. Okay, so looking at question 9, which expression is equivalent to 4a squared minus 9b squared? So this is very similar to a question that we had in part 1. So you have to be careful. Recall that a squared binomial really means that you're taking 2a minus 3b and multiplying it to itself. It will have a middle term. It's going to have 3 terms. It's not going to have 2. So you could use the box method or double distribute. But if you recall, we did learn some factor patterns for the difference of 2 squares. This is the difference of 2 perfect squares. 4 is a perfect square, its square root is 2. A squared is a perfect square, its square root is a. 9 is a perfect square, its square root is 3. And b squared is a perfect square, its square root is b. So I have the difference of 2 perfect squares. We learned during the year that if we have a squared minus b squared, it comes from the binomial of a plus b times a minus b. So essentially, if you have 2 binomials that have the same thing in both binomials but opposite signs, you're going to take the first term and square it, get a squared, minus the second term and square it. So vice versa, if I'm going to go from here to here, if I have the difference of 2 perfect squares, I'm going to take the square root of each one of these and put those values here in both of the parentheses and put a plus and a minus. So the square root of 4a squared is indeed 2a, right? And the square root of 9b squared is indeed 3b, but we need to have a plus and a minus. And the only one that matches this is answer C. Now again, if you wanted to, you certainly could have multiplied these out, but this one right here, well, or this one, most likely A is the one that y'all would have chosen because you would not have multiplied it by itself. You would have just tried to square this and square this. So you've got to be careful. All right, look at question 10. Okay, so as we look at this, we've got 2 lines that are parallel, the f function and the g function. And we have to figure out what transformation will map this one onto this one. So they have some kind of odd answer choices, one that we're not used to. So I'm going to make this a little bit bigger so that we can try to follow their answer choices. Okay, so we always have to go from the f function to the g function and follow their choices. So a horizontal shift, left 12. Horizontal means we're going right and left. And so to go 12, I want to start way on the right if I'm going to go to the left. So I'm going to choose a nice whole point. In other words, this right here is not a whole point because it's not where two grid lines cross, but this one is. So if I can take this point and shift it, and in fact, let me put a point right here so we can see where we started from. So if I can shift that left 12 and I get an identical point on g of x, then that's a possibility. So let's go left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, whoops, 12. So that does seem to work. So that would end up putting us right here, right there. All right, so A seems to be a definite possibility. Now, horizontal shift left 6. Well, if we had stopped at 6, 1, 2, 3, 4, 5, 6, we would not be touching the G graph. So it could not possibly be B. A horizontal shift right 6. Well, if I shift right 6, let's start maybe here. If I go right 1, 2, 3, 4, 5, 6, I'm not anywhere near the G function at all, so it cannot be C. A horizontal shift right 12, and for the same reason, a right shift is not going to work at all, so the answer definitely is A. Is that it? Okay, so next question. So question 11. The question is 3, 5 a point of intersection for these two functions, and why? So we're going to actually have to, like we did with the previous question, plug in our x value of 3 and our y value of 5 into both equations, and it's got to make both equations true. Remember, f of x and g of x are the same as y, so this is y and that's y. So I'm going to start off with the first function. So I'm going to take, whoops, instead of y, I'm putting in a value. So instead of y, I'm going to put in 5 equals 2, and instead of x, I'm going to put in 3, and then minus 1. So we have 5 equals 2 times 3 is 6, minus 1 is 5, so that definitely checks. Then the other equation, instead of y, we're going to put in 5 again, equals 1/3 times, and instead of x, we're going to put in, and I'm going to make it 3 over 1 because we're multiplying 3 to the fraction 1/3, so I always want a fraction being multiplied to a fraction, and then plus 4. So the left is 5, and then 1 times 3 is 3, 3 times 1 is 3, plus 4, so 5 equals 3 divided by 3 is 1, because that's a 3, it's hard to see, plus 4, 1 plus 4 is 5. So it does, it is a solution to both equations, so they have it in common, therefore that is their intersection. And so my answer should be yes, but we have 3 yeses and 1 no as a choice. So answer choice A says yes, the intersection 3, 5 lies on the graph of f of x. That is true, it does lie on the graph of f of x, but it also lies on the graph of g of x. And so B is just saying g of x and C is saying for both. So I'm going with answer C because that's my best answer choice. Even though A and B are technically correct, C is the better answer. Question 12. In a football game, Sebastian scored points by kicking the football through the goalposts successfully 9 times. So that might be an important fact. Successfully 9 times. Okay? Each of the successful kicks was worth either 1 point, an extra point after a touchdown, or 3 points, a field goal. Sebastian scored a total of 7 points as the kicker. How many 1-point extra point kicks did Sebastian successfully make? So he scored a total of 7 points as the kicker. So you can do a couple of things. We want to have a total of 17 points. So you could guess and check your way to the answer. You could set up an equation to solve. But let's just take our choices A, B through A through D, and then we're going to set up a table and see is that possible. So this will be extra, and this will be field goal. So I'll just put FG. So for answer choice A, if we had 4 extra points kicks, then that would give us 4 points. And then 4 plus what is 17? So that would have to be 13 for it to equal 17. Now these field goals, they have to be a multiple of 3 or divisible by 3, however you want to look at it. Because the field goals are 3 points. So if we had 13 points in a field goal, it has to be divisible by 3. That's not possible. So this cannot be. So we could not have had 4 extra points. So let's look at 5 extra points. So that would give us 5 points here. 5 plus what is 17? That would be 12 to equal 17 total points. 12 is divisible by 3, so this is a possibility. Look at answer choice C. 6 extra point kicks. So we'd put 6 here. 6 plus what is 17? That would be 11 to make it equal 17. 11 is not divisible by 3, so that is not going to be an answer choice, so we're throwing C out. And then D says 9 extra point kicks. So we're going to have 9. And then 9 plus what is 17? That would be 8 is equal to 17. 8 is not divisible by 3, so our only answer choice could be B. Moving on. All right, so question 13. Study the parabola in the coordinate grid. What is the vertex? So the vertex, which is your max or your minimum point, because this parabola opens down, the vertex is going to be here up top, and that is a maximum. Top is max, bottom would be a minimum. And that ordered pair is at an x value of 4 and a y value of, it looks like 2. And the x-intercepts. So the x-intercepts are the zeros or the roots or where the graph is crossing the x-axis. See that one? So your x-intercepts would be an x value of 2 and a y value of 0, an x value of 6 and a y value of 0. So the only one that has both of those correct would be answer choice B. Okay, question 14. When at a conference, Mr. Gary rented a car for a fee of $62.50, plus 12 cents per mile he drives. So the $62.50 is a flat fee. He could drive no miles and still be charged the $62.50. But then he's going to be charged an additional amount of 12 cents per every mile he drives. So we could actually set up an equation that total cost is equal to, and they're going to want to do C of x, but total cost is equal to our flat fee of $62.50, and then we're going to add to that 12 cents per every mile. So I'm going to use, I don't know, M for miles. What is the most miles Mr. Gary can drive without spending more than, okay, I can't see what that says, $320. So our cost is capped at $320. So that the cost has to be less than or equal to, I'm reading from left to right, cost has to be less than or equal to $62.50 plus, well, okay, no. I want to do this the other direction. I don't like the way I wrote that because we're going to have the inequality sign wrong. So let's think about it this way. Let's flip the equation around. I'm going to flip it backwards. $62.50, it's our flat fee, plus our 12 cents per mile, cannot, so it has to be smaller. The left side, this cost, has to be less than or equal to our cap of $320. Yeah, that's better. Okay, so M is my miles, and I want to figure out how many miles this is going to give me. So I'm going to get miles by itself. That means I want to move the 62.50. The opposite of a positive is a negative, so I'm going to subtract 62.50 from both sides. So I get 12 cents per mile. My inequality sign only changes if I multiply or divide across the inequality, both sides, by negative, so it stays the same. And then 320 minus 62.50 is $257.50. So then to figure out how many miles, we have to undo 0.12 times M by dividing by 0.12. 12 100ths. And we get M equals, because I did not divide by a negative, we still have a less than or equal to. We're going to take that 257.5 and divide it by 0.12. And we get 2,145.83 repeating. So the closest answer that is less than 2,145.83 miles is B, 2,145 miles. Next. Okay, so question 15. A line segment is graphed on a coordinate plane with endpoints located at -6, -2, and 6, 6. What is the slope of this line segment? So remember, slope, which we use as M, has a formula, y sub 2 minus y sub 1. We use this formula when we have ordered pairs. X sub 2 minus x sub 1. So I'm going to label these. It doesn't matter which is x sub 1, y sub 1, so long as the sub 1s stay with the same point and the sub 2s stay with the same point. I'm going to label these. And then I'm going to rewrite my slope formula as a template. I'm going to remove all the variables and replace them with what I've labeled them as. So y sub 2 is 6, y sub 1 is -2, x sub 2 is also 6, and x sub 1 is -6. We want to take care of our double signs, so we're going to add the opposite by doing plus plus and plus plus. So we get 6 plus 2 is 8, 6 plus 6 is 12. We can divide both of these. The biggest number you can divide them both by is 4. And so we get a slope. 8 divided by 4 is 2. 12 divided by 4 is 3. So answer B is our correct answer. Question 16. What is the slope of this line? So this time we've been given the graph. So we're going to view slope not as the slope formula that we used above, but still view it. My iPad is falling a little bit behind. So we're going to view it as rise over run. So our up, down versus our right, left. So you want to choose 2 points that are nice, perfect integer points where the grid lines are crossing. So I'm going to choose that point and then the y-intercept. So I'm going to find my rise. My rise would be from here to here. So that's 1, 2, 3, 4. That's a +4 direction. So my rise is going to be positive 4. And then my run is to the left. So to the left is a negative direction, 2. So negative 2. And then 4 divided by negative 2 is negative 2. So B is our solution there. Last 2 questions. Yippee skippy. All right, here we go. Well, it's bothering me. It's crooked. It's close enough for government work. Okay. Question 17. A farmer measures a corn plant as it grows. He records his measurements in the table. So day 1, we get 2 inches. Day 4, which happens to be a difference of 3 days, we get a difference of 6 inches. Then day 4 to 10 is a difference of 6 days, and we get a difference of, from 8 to 14 is 6 inches. And then from 10 days to the 28th day, that's a difference of 18. And then from 14 to 20, we have another 6 inches. So as the days are increasing, and not by a constant amount, 3, 6, 18, the height is increasing by a constant amount of 6 inches. So what is the average rate of change in the height of the corn plant from day 4 to day 28? So we actually want to go from, so let me erase these since it's really not a linear function. So they're only choosing 2 of the ordered pairs. So we're going to go from day 4 to day 28. So that is a difference of 24 days. And then that would go from 8 to 20, which is a difference of 12 inches. So average rate of change, this is going to represent our x, and this is going to represent our y, because x is our independent variable, and we cannot slow down or speed up time, which is our days. So remember, for our slope, if it's rise over run, or change in y, because our difference in our y's, that would be our rise, and our difference in our x's. So our y difference was 12, and that's inches. And our x difference was 24, and that's days. So we're going to actually take 12 and divide it by 24, and that does give us 0.5 inches per day. And that would be answer A. Last question. Yay! You've made it. All right, Giovani drops a rock from the Leaning Tower of Pisa in Italy. So let's draw a little picture of what's going on. I'm excellent at drawing. So there's my Leaning Tower of Pisa. And then you've got Giovani right here. He's dropping a rock. Now, because of gravity, this rock is going to actually make a parabolic path. So we see part of a parabola. The height in feet of the falling rock above the ground is given by the following equation, where t represents the time in seconds. Approximately how long will it take the rock to reach the ground? Well, the height at the ground is 0. So h is your height. So we are going to let h equal 0. So in this equation right here, we're going to replace h with 0 equals negative 16 t squared plus 186. So what you can do is put this into your calculator and graph it. Now the problem is you're going to be at 186. That is what you're looking at right here. So Giovani is at a height of 186. That's what that represents. It's not going to show up on your calculator, so you're going to have to adjust your window, knowing that this would be really no different than if this were our y-axis, and then where the ground is our x-axis. So this would represent a 0 where it's hitting the ground. You are going to get a negative value over here on the left because the graph doesn't realize that this is a real situation. So we're going to ignore this 0 and only look at this one. So we're going to have to zoom our graph out. So go ahead and go into your graphing function, clear out anything that's already there, everything. And in the first line, you're going to put in that equation. So I know it says t squared, but we're going to use x. So negative 16, instead of x, we're going to put in our calculator a t. To square it, use the x squared button or caret 2, and then plus 186. And then hit enter or execute, and then hit draw or graph. Now, your screen actually probably will show it'll look like 2 straight lines. So on your calculator screen, so if this is my calculator down here, this is my viewing window, if you will, you're going to see this as your x and y axis in the middle if you have the standard viewing window. And your graph is actually going to look like this right now because it's showing very straight lines for the parabola because it's pretty tall all the way up to 186 on the y-axis. But this is right there, the 0 we're looking for. So you shouldn't have to zoom in or out. So if you go to your G-solve on the Casios or second calc on the TI, and we want to find zeros, so choose the command for 0 and make sure that you choose the right 0. Let me get my correct function. Hang on, I'm getting there. Oop. Okay, so I get 3.4 for my x. So this value right here for my x is 3.4. And you should see your y being 0. So that matches. X is my t. And so how long will it take? 3.4 seconds. All right, good luck on that EOC benchmark.